What I like is a high average and a low standard deviation. You know why I like that? High average, low standard deviation. Why does that make me happy? Because we're getting super consistency, and we're super consistent around a high average. We're clustering towards a high average. What gets me nervous, a little bit more nervous, is a high to low high average and a high standard deviation. That means I'm getting buckshot. What gets me really depressed is a low average and a low standard deviation. That means, again, we're super highly compressed around a crappy score. I don't like to see that. I don't see that. Go ahead, Armando.
We're consistent. So.
You are consistent. What's that Bob Uecker from Major League? How these guys lay on pitches that consistent after 12th ball in a row? I do love that. Consistently awful. We try to avoid that here. Try to avoid consistent awfulness.
We'll go for consistent.
We'll go for consistent excellence. And it always happens. I mean, it just historically, anecdotally, that's what happens. But that's the problem I have when points are simply added to assessments. Because I'm not sure that's the best thing to do. Because you might be ignoring the symptom of the problem. You're treating a symptom, but not looking at the root of the problem, which is why it happened in the first place. So, yeah, good. Anything else variation-wise? We'll talk about your exam. Let's talk about the exam a little bit. Should I keep this recording, the exam bit? Yes. Yes, don't touch that button rule. Touch that button. Son of a... Yes, let's let it run. I didn't bring a little rag, so I'll have to use this. Perfect. Okay, so the way this exam is going to be is it covers 3 sections. We're going to do some more stuff today. We're going to start what's called relative position today, which is a super interesting part of the course. And it marks kind of the beginning of the transition of our course from statistics to probability in statistics. But what we do after the break today won't be on the exam on Wednesday. It'll be on the next exam, which is like week 6 or week 7, or whatever it is. Okay? So this is exam number 1, in purple, because that's what I grabbed. Yay. So 3 sections. And if you're looking at your homework, it's just the first 3. You got the intro to prob and stat. You got central tendency. And you got variation. Yeah. What do you remember from these sections? What do you remember? Let's just do a buckshot kind of treatment of, throw out some topics from any section, or any topic that you remember, even if you don't remember what section it's from, just throw me the topic out.
Like descriptive.
Descriptive versus inferential. Absolutely. Let me think. Yes, and I can tell you exactly the type of problem I'm going to be asking from that. So Haley she opened up actually a great Pandora's box of ideas with that one. She said descriptive, which is the complementary type of stat to inferential. Now, in case you don't remember, and that's okay, descriptive stat is, actually I'll just ask you, what is descriptive statistics? What kind of? Say that again?
Describes it.
Right. Does it try to infer anything? Does it try to make a hypothesis or make a prediction? No, that's the inferential bit. So rather than make you do definitions for this kind of a thing, what I'm going to have to do, what I had you do instead, there were some couple of homework problems that were great, where they gave you like a little bit of reading. Like it said in the United States that 62% have, I don't know, eczema. That's too high, but whatever, 62% have eczema. We take a random sample of 1,000 Americans, and in that random sample we find that 58% have eczema, plus or minus 4% is the margin of error. And what I do is I made a matching problem up for that, where I put like parameter, statistic, margin of error, sample, and you have to match up. And then on the other side I have the actual things like the 62%, the 58%, the plus or minus 4, which is the parameter, so you don't have to memorize the definition, but you do have to know, you have to have the knowledge of what these terms mean. So let's make a laundry list of the terms you're going to want to know from that bit. So make sure you know what a parameter is. Make sure you know what a statistic is. Make sure you know what a margin of error is. I'm not going to ask you to define these things, but I'm going to ask you to use them contextually. Make sure you know how to apply a margin of error to a statistic, the plus or minus bit. So 58, what does 58% plus or minus 4% mean? What does it create? It creates a rate. And there was actually some homework problems in this one that actually dealt with that too. A little bit of plus or minus. Make sure you know what a sample is. The population, I didn't harp on that one only because very often you can't enumerate it. The idea is here is I've actually enumerated the sample for you in the problem, so you'll actually have like, I randomly sampled 1,068 COCC students. Oh, well there's the sample, 1,068 COCC students. So I didn't enumerate the population because it's changing, number one, and you can't usually get it, number two. Fair enough?
And for example, you have a look at the page 20 and the problems from 27 until 31.
Is that these kinds of things?
I don't know. I was going to ask you because they want you to think about it. Those are a little too open-ended for the in-class bit. Let me see if. I mean, there were some problems concerning like parameters.
Yeah, look for the ones where.
Not these ones.
Right. Those are open-ended, and I love open-ended questions, but I like them more for the out-of-class assessment. Oh, I like them when you're not under the gun to do it. That's when I like them. Yeah. No, not the in-class.
Okay.
The in-class I like to keep it a little more straightforward. Okay. The out-of-class ones I can stretch out and make you guys write sentences and stuff. Okay. So like for example, on the exam I say, based on what you just did in Excel, how would you answer the question, how many eggs do you get from your chickens? I love that question because I can have a bazillion different answers for that. Now, it drives you guys nuts on a timed assessment because you're like, I want x equal to 2. Well, that's fine, except so the idea basically becomes I keep it a little more simple in class. What else? Well, go ahead, David.
It's not a silly question.
Good. None of them are.
Difference between sample and population?
As far as the definition, don't sweat it.
Okay.
Being able to identify them actually within the context is the important thing, right? I don't want this to be a term exam. I want it to be a using the term exam, which is why I like this. Go ahead, Anthony.
Qualitative, quantitative, and discrete.
I didn't do that because I had that on the quiz from last week.
Okay.
So I figured rather than just make this two-termy, leave those off. You guys obviously kicked ass on that quiz, so I say ass on YouTube. I guess I said it twice. But yeah, so you're solid there.
So
cool.
We're not gonna have to know the discrete.
Nah, that was on that quiz. You guys did great on it. I mean, I like to put things in assessments that I haven't assessed other places yet, and you guys already nailed that, so we're good. Cool. Anything else? What else? You used a bunch of terms today. What's some terms we used today? Mean. Mode. Median. Central tendency. Right. You got the mean. You got the median. You got the mode. Yeah, make sure you can calculate all those things. And use your technology. Use your technology. Make sure you can calculate S. And make sure you can calculate them both from raw data and also from grouped data. So when I say grouped data, the quiz that's due on Wednesday and the quiz that was due last week, I haven't gotten it back to you guys yet because I haven't gotten it back from Amber yet, but the quiz that you guys turned in last week, I would think it was Old Faithful eruption times. Those Old Faithful eruption times is a great example of grouped data. When you have to look at the distribution and pick the middle value in each and use that.
So then visual.
Exactly. So I may have just made it distribution. I can't remember now. It doesn't matter. Either way, I think I didn't make it visual actually, Haley, because on the exam it's actually easier for you guys not to have the visual,
Right.
because then you can just drop the middle value next to the frequency and then put it directly into your TI. So I guess what I'm getting at is make sure you can do both raw data and also grouped. And I use raw and grouped A and B. I use raw and grouped in quotes because they're kind of like the terms I always use. Raw versus grouped is like loose data versus a weighted mean. So this is like a traditionally calculated mean like we did over here. And grouped is, that was like 2 O's. Grouped data would be a weighted mean, where you've got data and then a frequency column that tells you how many times to count each one. So the difference, technologically speaking, you remember this, I know, is that you use one var stats by itself for raw, and you use one var stats exactly L1 comma L2.
That was my mistake.
Yeah, and that's exactly why. So I go back to what I said. I don't like to assess repeatedly on things that that you've already learned very, very well, because once you kind of check something off, okay, they've got that, they've got that. This is the kind of thing that tends to throw students. So I like to have it in a number of times. Quiz last week, quiz this week, on the exam again, just a number of assessments because it's that important. This is how you're going to get data when you look at like a research project. Very often the data comes to you grouped in a distribution, you have to deal with it, and that's the perfect way to deal with that. So you'll have, like I said, one of each of those. Cool? And then, but pretty straightforward. Pretty straightforward as far as, I'll ask you things like, what is the average? What is the standard deviation, and so forth and so on and so forth and so on. Like what is? Yeah.
Is absolute value going to be good?
Absolute value.
Yeah. PSS.
Oh no, that PSSC question. No, that was a measure I brought up in class last week because you guys were asking me. We were talking about how I said, how would you describe this data? Oh, it's bell curve. Oh, it's symmetric. Oh, it's yeah. And then I said, okay, no data is perfect. Data is never perfectly bell-shaped. It's always got a little bit of skew to it. That formula, that PSSC formula, is one way to measure skew, and it involves the absolute value. No, I didn't put the PSSC on there because I tried that one time years ago and it backfired horribly. So I just left it off. Now there is an extra credit, I believe, on your take-home that asks you to figure out which command you need to get the PSSC on Excel. So it's there on your take-home if you want the extra credit point. But no, I didn't. I left that off the in-class exam because that's too much of a.
Is that the third quiz? Right there?
I think she's referring to the third quiz and also a homework from variation.
Wow.
So we started looking at like E6 and E7 today. You can look back like up at E1, E2, and E3. It refers to the Pearson something coefficient, something skew coefficient, and what that is a way of quantifying or quantifiably measuring how skewed something is, and it involves the absolute value. And because it's very mathy and very kind of intricate, it doesn't do well on in-class exams.
But my question is, I think when I read something, it says absolute value, what does it mean? I mean, that's exactly what it means.
What does absolute value mean?
Yes, it means that.
That's like a Math 95 type question. I wouldn't ask that in here.
Okay.
The definition of absolute value is distance from
like
zero. I
in
wouldn't ask.
general.
I wouldn't ask that in here.
Okay.
I mean, it's fine in a homework question to kind of have you think about it, but I'm not going to ask you on an
Okay.
exam because I mean, you took Math 111 and survived that war. So there's no reason to put you through that battle again. Cool? And I do like to, in this, it kind of goes in this section, I like to analyze a visual. So if you look at, let's not put in quotes, visual analysis. If you look at, I found a really great one from National Geographic that I want to put on this exam. If you look at the homework from that section, I put up a couple pulled from the news kinds of graphics. One talks about student debt, using balloons for student debt. And the problem with media when they do that sometimes is they skew what they're actually trying to show. And there's some geometric issues that usually happen. And that the homework set has a couple good examples of that in there. So I pulled a really cool one. I was reading through National Geographic from a couple months ago, and a really neat one popped up involving how much food is consumed in the world and what types of food are consumed. And it falls into that category of problem. So when you look at that problem, there's one or two problems in that first bit. They're E problems, where you look at a graphical display and you analyze the numbers that are in the display, and you try to see if what's being shown to you actually is indicative of what the numbers actually are. So pay attention not just to those problems, but also the solutions to those problems underneath, to make sure that you can see why they either are or are not good examples of visual displays. So we'll start with that one. And I guide you through that one because it's an E problem. It's got quite a bit of open-ended kind of analysis. So what I do is in that problem, I'm going to set it up very steppy. Like, look at this. What is this? Look at this. What is this? Let's compare. What's the ratio of that to that? Okay, now look at that. Look at this. What's the ratio of that to that? And we kind of walk you through it. So just be comfortable with that kind of. Don't worry about memorizing that question from intro to prob, but just be ready for one of those. Because it popped out when I was reading National Geographic. Like about 2 months ago, it just worked beautifully. And I got it set up in a way I think this would be awesome for you guys. You're all gonna crush it. Plus, you'll learn how to analyze what you see in the news too, even more. So, yeah, I guess that's. Go ahead, Haley. What's that question? Go ahead.
No,
Oh, I just motion.
no, I don't have one.
I see
No.
motion.
So, exactly.
Sneeze again. I just wrote another sneeze for.
Yeah.
Is absolute value negative?
No, it can never be negative. That's the definition. It's distance from zero. It says it's distance. you can never have a negative value. Yeah. Cool? Let's take 5. Let's take, that's your exam. That's your exam. You're going to crush it. You're going to crush it. I'm not worried at all. You are. You're going to crush it. You are. I'm not worried. Take 5. Get some air. Get some water.